Do you want to know how your computer or smartphone can show text, images, and even play music? The secret is the binary code, the language of computers made of just zeros and ones. In this video, we'll break down how text, images, and sound are converted into binary, what 0 and 1 really mean, and why this is of significance for file compression. Let's dive right in. What is binary code? Binary code is a system of numbers using only 0 and 1. Each 0 or 1 is called a bit, and a group of 8 bits makes a byte. Think of it like a light switch. 0 means off, 1 means on. Computers use billions of these switches known as transistors that rapidly turn on and off to process everything you interact with on your device. In essence, binary is the only language computers truly understand. Let's start with text. Computers don't understand letters, they understand numbers. Every letter or character is assigned a number using ASCII or Unicode. For example, the letter Z becomes 90. Then that number is converted into binary, so 90 becomes 01011010. Another example is when you type a word hello, it's converted into this. Fun fact, emojis like the smiley face are encoded using code points that are also then translated into binary. So, when you type a message, your computer is really storing and processing a long series of zeros and ones behind the scenes. Not just letters, computers also convert numbers and decimals into binary. Whole numbers are straightforward. For example, the number 5 becomes 101 in binary. Decimals are a bit trickier. Computers use a system called floating point representation. For instance, 5.25 in decimal becomes 101.01 in binary, which splits the decimal number into a whole part and a fractional part. Next, let's look at images. Every image is made of tiny dots called pixels. Each pixel has a color value, usually broken into red, green, and blue, or RGB. Each color value is converted into binary numbers. For example, the RGB for pure red color consists of values of 255 for R, 0 for G, and 0 for B, which is in binary looks like this. So, when you look at a photo on your computer, you're actually seeing millions of these binary numbers working together to create the colors and the shapes. What about sound? Computers store sound by sampling it into tiny chunks. Each sample is converted into a number representing the sound wave's height using an analog to digital converter, and then into binary. To play the sound back, the process is reversed using a digital to analog converter. So when you play a song or a notification sound, your computer is actually reading billions of zeros and ones and turning them into the music you hear. Additionally, binary is also key to file compression. Computers can find patterns in binary numbers and store them more efficiently. For example, if a text file has repeated letters like AAAA, instead of storing this 4 times, compression can store 4A in binary form to save space, which means instead of taking 4 bytes of storage, it now only requires 2 bytes of storage. In other words, a 50% reduction in storage consumption. This compression is basically how formats like zip, JPEG, and MP3 reduce file sizes while keeping your data intact. So, now you know how binary code turns text, images, and sound into zeros and ones, and why this is the foundation of all computing. If you want to request any other specific computing foundation, please let me know in the comments below. Thank you for watching. Don't forget to subscribe and hit the notification bell to stay updated with more computing bite-sized learning. If you find this video helpful, smash that like button and please share this video. See you in my next video to learn computing in a more fun way.